Today our class is instrument about breadboard, multimeter and DC power supply. Here is our contents: 1. Breadboard, 2. Multimeter, 3. DC power supply. In each chapter we'll introduce what is this instrument's feature and how to use it. 1. Breadboard 1.1 What is a breadboard? A breadboard is a rectangular plastic board with a bunch of tiny holes in it. Show in Fig 1.1, modern breadboards are made from plastic and come in all shapes, sizes, and even different colors. Full size, half size, mini size. Technically, these breadboards are called solderless breadboards because they do not require soldering to make connections. Show in Fig 1.2, breadboards are designed so you can push these leads into the holes. They will be held in place snugly enough that they will not fall out even if you turn the breadboard upside down, but lightly enough that you can easily pull on them to remove them. 1.2 What is inside a breadboard? Show in Fig 1.3, the leads can fit into the breadboard because the inside of a breadboard is made up of rows of tiny metal clips. This is what the clips look like when they are removed from a breadboard. Show in Fig 1.4, when you press a component's lead into a breadboard hole, one of these clips grabs onto it. Show in Fig 1.5, some breadboards are actually made of transparent plastic, so you can see the clips inside. (1.3) What do the letters and numbers on a breadboard mean? Most breadboards have some numbers, letters, and plus and minus signs written on them. While their exact appearance might vary from breadboard to breadboard, the general purpose is always the same. Show in Fig 1.6. These labels help you locate certain holes on the breadboard so you can follow directions when building a circuit. Show in Fig 1.7. These strips are typically marked by red and blue or red and black lines, with plus and minus signs, respectively. They are called the buses, also referred to as rails, and are typically used to supply electrical power to your circuit when you connect them to a battery pack or other external power supply. (1.4) How are the holes connected? The inside of the breadboard is made up of sets of 5 metal clips. Show in Fig 1.8a. This means that each set of 5 holes forming a half row, columns AE or columns FJ, is electrically connected. For example, that means hole A1 is electrically connected to holes B1, C1, D1, and E1. It is not connected to hole A2, because that hole is in a different row, with a separate set of metal clips. It is also not connected to holes F1, G1, H1, I1, or J1. Because they are on the other half of the breadboard, the clips are not connected across the gap in the middle. Show in Fig 1.8b. Notice that the power bus was not connected together of some breadboards. 1.5 How to use a breadboard. To understand this, it helps to understand how a breadboard's holes are electrically connected. There are different ways to change the physical layout of a circuit on a breadboard without actually changing the electrical connections. Show in Fig 1.9. There are 2 different connection type of component. Fig 1.9a shows the resistors connected in series. Fig 1.9b shows the resistors connected in parallel. Show in Fig 1.10. Many ICs come in something called a dual inline package, or DIP, meaning they have 2 parallel rows of pins. The gap in the middle of a breadboard between columns E and F is just the right width for an IC to fit, straddling the gap, with one set of pins in column E, and one set of pins in column F. Projects that use ICs will always tell you to connect them to the breadboard in this manner. Show in Fig 1.11, short circuits on the breadboard. Show in Fig 1.12, getting row numbers wrong. Show in Fig 1.13, putting components in backwards. Show in Fig 1.14. Not pushing leads and wires in all the way. Show in Fig 1.15, getting power and ground mixed up. Multimeter 2.1. What is a multimeter? Multimeter is a multi-functional electrical measuring instrument. Its main function is measuring of characteristics of electric signal. Multimeter combines functions of an ammeter, a voltmeter and ohmmeter as well as other electrical measuring instruments. 2.2. What are the main functions and features of multimeter? Measuring of voltage of direct current and alternating current. Measuring of resistance and electrical capacitance. Measuring of diode and HFE of a transistor. 2.3. What are the types of multimeter? Analog multimeter show in Fig 2.1. Advantages: possibility to carry out measurements at low temperatures down to -30 degrees C. Fast operation with a large amount of measurements, when high precision is not required. Do not require power consumption from the built-in power supply in the mode of voltage and current measurement. Instant display of the dynamics of the signal change. Disadvantages: nonlinear scale and setting 0 before starting measurements. Absence of automatic detection of voltage polarity. A small set of functions. Most models can measure only DC and AC voltage, DC current and resistance. Low input resistance and, consequently, a high error in low voltage measurements. Sensitivity to mechanical damage. Vibration. Digital multimeter show in Fig 2.2. Advantages: maximum possible measurement accuracy. Automatic polarity detection, if the probes are connected incorrectly. The correct values with a minus sign appear on the screen. Possibility of automatic and manual selection of measuring ranges. Multifunctionality, does not require mandatory zero adjustment. The accuracy of the meter reading does not depend on the battery charge. Resistance to mechanical damage. The ability to record measurement results in memory and synchronize with a PC. What are the types of digital multimeter? Digital multimeters can be classified by number of digits, accuracy class, size, protection class. Availability of additional functions or other parameters. For example, depending on the size and purpose of models is divided into 4 groups. Compact, medium-sized, standard, large portable benchtop show in Fig 2.3, the most commonly used type. What do all the symbols on the front of the multimeter mean? Voltage, current, and resistance have units of volts, amps, and ohms, which are represented by V, A, and omega respectively. Most multimeters use these abbreviations instead of spelling out words. Your multimeter might have some other symbols, which we will discuss below. Most multimeters also use metric prefixes. Metric prefixes work the same way with units of electricity as they do with other units you might be more familiar with, like distance and mass. Micro 1 millionth 10 to 6 m milli. 1,000th 10 to 3 k kilo, 1,000, 103 m mega, 1,106. Some multimeters are auto-ranging, whereas others require you to manually select the range for your measurement. If you need to manually select the range, you should always pick a value that is slightly higher than the value you expect to measure. Say you are going to measure the voltage of an AA battery, which you expect to be 1.5 volts. The multimeter on the left in figure 2.2 has options for 2 volts, 20 volts, 200 volts, and 1000 volts for direct current. You would pick the value that works, 2 volts. All of the other options are unnecessarily large, and would result in a loss in accuracy. 2.6 What do the other symbols on the multimeter mean? Here are some common symbol on the multimeter in Table 2.1. Squiggly line. You might see a squiggly line next to or above a V or a on the front of your multimeter, in addition to metric prefixes. This stands for alternating current AC. Solid line or dashed line. Like the solid line, you might see this next to or above a V or an A. The straight lines stand for direct current. You use these settings when you are measuring a circuit with direct current. Resistance. Resistance is the measure of electrical friction as charges move through a conductor. It is measured in the unit of ohm, that unit symbolized by the capital Greek letter omega, omega. Set your multimeter to the highest resistance range available. The resistance function is usually denoted by the unit symbol for resistance, the Greek letter omega, omega, or sometimes by the word ohms. Continuity check, series of parallel arcs. This is a setting used to check if two things are electrically connected. The multimeter will beep if there is a conductive path between the two probe tips, meaning, if the resistance is very close to zero, and will not make any noise if there is no conductive path. Diode check, triangle with some lines through it. This function is used to test a diode, which is like a one-way valve for electricity, it only lets current flow in one direction. 2.7 What are the red and black wires probes? Your multimeter probably came with red and black wires that look something like the ones in figure 2.4. These wires are called probes or leads. One end of the lead is called a banana jack. This end plugs into your multimeter. The other end is called the probe tip. This is the end you use to test your circuit. Following standard electronics convention, the red probe is used for positive, and the black probe is used for negative. Although they come with two probes, many multimeters have more than two places in which to plug the probes, which can cause some confusion. Exactly where you plug the probes in will depend on what you want to measure and the type of multimeter you have. This multimeter has three different ports labeled 10A. COM, which stands for common, and V omega Ma. There have provided some connected examples in the Fig 2.6 and Fig 2.7. How to measure HFE of a BJT by multimeter. It is very important method to measure a transistor. Step 1. Confirm the type of a BJT and its pin configuration. Shown Fig 2.7. The BJT C1815 is a NPN type and its pin configuration from left to right is emitter, collector, base. You can search the datasheet by Google. Step 2. Select the NPN level on the multimeter. Step 3, shown Fig 2.8, plug in the corresponding pin and it will show the HFE of a BJTC 1815. 3 DC power supply 3.1 What is the DC power supply? The DC power supply is an electrical device that supplies electric power to an electrical load. The primary function of a power supply is to convert electric current from a source to the correct voltage and current to power the load. The DC power supply is one that maintains constant output voltage despite variations in load current. Show in Fig 3.1. A typical DC power supplies allow the output voltage to be programmed by mechanical controls, e.g., knobs on the power supply front panel. What are the main functions of the DC power supply? Show in Fig 3.2, the control panel of the power supply with the important controls labeled. Provided a constant DC voltage from 0 to 30 volts. Provided a limited DC current from 0 to 3A. How to use DC power supply. Plug in the crocodile clip, red wire for positive plus, black for negative. Open the output crocodile clip. Show in Fig 3.3. Rotating the voltage knob clockwise to set the desired voltage. Rotating the current knob clockwise to set the limit current. Note: do not to exceed the limit current for the wire or component. Press Output Enable button. What is the output mode of DC power supply? The DC power supply can be operated in 3 different modes, and each mode changes the way both channels behave. There are 3 different modes. Show in Fig 3.4, independent mode voltage range is from 0 to 30 volts, current range is from 0 to 3A. Show in Fig 3.5, series mode voltage range is from 0 to 60 volts, current range is from 0 to 3A. Show in Fig 3.6, parallel mode voltage range is from 0 to 30 volts, current range is from 0 to 6A. Table 3.1 contains a summary of the power supply modes, and which controls are applicable for each mode. In Table 3.1, summary of the different power supply modes. First, assume DC power supply set in independent mode. Both voltage knobs set the output voltages for both channels independently. Both current limiting knobs set the current limit for both channels independently. The channels are not connected together. Second, assume DC power supply set in series mode. The voltage knob for channel 1 sets the voltage for both channels. The current limit is set at the lower of the 2 current limiting knobs. The channels are linked in series, providing a bipolar supply. Final, assume DC power supply set in parallel mode. The voltage knob for channel 1 sets the voltage for both channels. The current limit is set by the channel 1 current knob. The channels are connected together in parallel, allowing you to supply larger currents.